previous videos, we have discussed about a flowchart showing an example of a research study made of 3 objectives. It provides information in terms of the stages of the research as well as their relationship between those stages, and also how those stages are designed to attain their respective objectives. This flowchart is a reflection to your research design for the one-to-one model. What you see here, the objectives of the research study plays a significant role in governing the entire research program carried out. Each of the objectives should be accompanied with a study program, which will be later being used at the later stage of your research study. A good research design must be optimized without any overlapping and also the redundancies. Every stage serves the purpose and play their roles in the entire research. This research design is an example where your research objectives are aligned in the linear manner, and the entire research is designed to attain the objective one by one. In fact, it is not necessarily the objective needs to be designed in the linear form. Although this is rather popular, it is dependent on your purpose of your study. Sometimes the objective can be attained in a parallel form, as demonstrated by the flow diagram here, which is another type of the research. Let us look into the details of this research for you to gain some ideas how a research is typically designed. Probably this can enlighten you in designing your own research study. For this research study, it is started with preparing the specimens for the experimental tests. The research is actually developing a new design, which is of course on basis of the literature review, and then you propose some design, and there will be detailing design and analysis. Once you have decided the respective design, then you have to prepare the specimens for the testing. It seems here is a concrete work where there is preparations of the formworks and reinforcement, casting of concrete and curing, and then testing of the specimens. This is a typical experimental testing. As the outcome of the experimental testing, there will be data and results. In terms of the results, these are the focus of the study. And then based on the result that you have acquired, you will need to derive empirical equations and to construct numerical models. The objective 2 and objective 3 will be on basis of the objective 1, which is very much dependent on the result as obtained from the objective 1. Based on the data and result that you have obtained from the experimental study, you will need to develop an empirical model using some statistical measures. First, you will need to define the parameters as implied from the experimental results. And then you might need to evaluate the significance of those parameters in governing the response of the specimens. There will be a series of statistical studies for you to decide whether to include the parameters or to exclude the parameters. You know that the contributions of some parameters are so minor that the variations in terms of the final result is not that significant. By ignoring those parameters, the predicted result given by the empirical equations will not vary significantly from the actual results. As a means to simplify the empirical equations, when you know that parameters is not contributing to significant changes in terms of the result, you may choose to ignore those in your model. And then you might need to determine the relationship of the parameters. Most likely the relationship in the form of linear regressions or some sort of the best fit trend line. Of course, this is dependent on the purpose of your study. In fact, you can actually create another line here doing the analytical study on basis of the first principles to cross-check with the experimental results. That is again depending on your purpose of your research study. As far as this study is concerned, most likely the first principles are still at the exploratory stage, where the theories and principles is not fully established yet. Empirical studies is used instead, and you choose to use these statistical measures for you to come up with the equations that closely trace the actual results for the applications at the later stage of your research study. When you have this empirical equation constructed, you will need to validate the equations. It is done by referring to the experimental result using the same set of the manipulated variables. Substitute into the equations. The predicted outcome are to be compared with the experimental results. You will need to check whether the predicted results is reliable or not. You will need to define the criteria for you to decide whether it is reliable. This can be quantitatively done by checking the predicted result within plus minus 10% from your experimental result and ensuring a majority of the specimen, let's say 80% of the specimen, fulfill the requirement of plus minus 10%. If you realize that your empirical equations is not reliable, you will need to redo this stage until you come to a situations your empirical equations are fully validated. Next, in your objective tree, you will need to construct a numerical model. This is something like the computations and simulations by some computer program in order to simulate the response of the specimen virtually. This kind of study normally will involve modeling of the materials. There will be assumptions in terms of the materials properties, which can either be acquired from the experimental testing or simply adopting some known value from your literature. Next, you will need to develop the model and virtually simulate the response of the model under the same load conditions and the boundary conditions. The simulated result needs to be validated also, which is again on basis of the experimental tests. You will use the same set of the manipulated variables from the experimental tests, and then your simulated results are to be compared against the experimental results and to check the reliability of your simulated models. And you should have a criteria for you to determine whether the models is reliable. Probably you are looking at the same standards for you to determine whether the empirical model is reliable. which you need at least 80% of the specimen, having the accuracy of plus minus 10% as compared to the experimental results. Now that you have 3 sets of results, one is from the experiment, second one is from the empirical equations, and the third one is for the numerical models. And you have checked the reliability of those models. Now you would like to investigate the behavior of the specimens. All these 3 methods here will bring you some meaningful informations in terms of the behavior of the specimens. For example, for the experiment, you will be able to see the crack patterns and the failure modes. You will also be able to observe the data and the response of the specimens, probably in the form of the deformations, the strength, the ductility, and so on and so forth. And then from the empirical equations, you might be able to project the trend beyond the boundary range of the parameters tested for the experimental program. If there is an obvious trend, you can simply extend the line, or using some mathematical approach such as differentiations and integrations for you to acquire additional understanding on the design. And then maybe from the simulations of the computers, you will be able to observe what's happening within the specimen, especially in the context of the stress and strain. You might be able to identify the regions where high stress is concentrated, helping you to identify the weaknesses of the design, which may not be able to be detected from the experiment. What you are seeing here, all these 3 objectives here, they also serving significant part of the research. They are actually providing the informations in different aspects for you to acquire a thorough understanding of the item. Based on the understanding that you have acquired, you are able to propose an optimum design. And this can help you to attain your objective 4, to propose an optimum design of something. What you see here, every single objective here are significant. They contribute a portions of the study program throughout your research. They are also offering good information to your research study, helping you to acquire better understanding on the topic that you are studying. There is no redundant here, as there are something unique that can be offered by one objective, which cannot be offered by the other objective. That means there is no overlapping in terms of the significant informations you want to acquire from those objectives. You know that your ultimate goal here is for you to acquire the optimum design. That will be your objective 4. And now all 3 objectives here is meant to achieve objective 4. You will see that now the relationship between the objective, it will be 3 parallel and then meeting at the end in objective 4. So this is another type of the research design, which is rather optimized, I would say quite impressive. And you know that every single one of these will constitute a lot of work. And you'll be able to imagine that most likely the amount of work for having 4 objectives here will be rather massive. Imagine that you have a research design with 5 or 6 objectives. How massive will your research be? It is likely reaching to a state that beyond the manageable level by a typical research student. Having this research design and this research design being introduced to you, I hope that you can gain some idea in developing your own research design. It will be very much dependent on your research topic as well as the purpose of your research study.